I know Elon's attitude towards AI, and he's very optimistic about its future, and obviously he's working on some of the most important AI areas, working on foundation, cognitive intelligence AI. His Tesla's working on autonomous vehicles, and Optimus is for humanoid robotics. These three areas of AI are the three most important areas of AI. And
we know some of you might be thinking, China is making significant strides in technology, not just in AI. And you're right, China is currently recognized as the global leader in high-speed rail, with trains that travel faster than any we have in the US. However, rather than being caught up in the quest for extraordinary feats just to get a wow from the crowd, American scientists are making a real difference, and it's something that can't be easily replicated. It's about focusing on creating innovative, sustainable solutions that seamlessly integrate into daily life. While China focuses heavily on export-driven infrastructure, the US is pushing the boundaries of technology, creating solutions that go beyond merely improving terrestrial transportation. We're talking about fully autonomous cars, robots with independent thought and action, electric flying taxis becoming everyday transportation, subways traveling freely underground. And, one day soon, we may even be able to freely travel to Mars or the Moon as if we're boarding a commercial flight today. To be honest, we take great pride in the high-tech products made in the US that have been developed to break through the current impasse. These innovations take a reverse approach to industry trends, focusing on durability, practicality, high performance, and, most importantly, being generation neutral with affordable prices for the average consumer. So, what are American tech scientists up to? What groundbreaking technologies can we expect in the near future? Welcome to Tesla Car World. Stay with us, and in just 1 minute, you'll get a glimpse of 6 revolutionary inventions set to launch in the US soon. And join over 258,386 Tesla fans who get updates here before the media does. Subscribe today.
It will be an age of abundance, the likes of which people have almost no one has envisioned. It'll be something special.
These innovations aren't just for tech enthusiasts or billionaires. They will impact you. They make your travel easier, the air cleaner, and traffic more efficient. They're changing the way we move, making it faster, greener, and safer. These advancements are paving the way for a future where you can travel farther, faster, and with less impact on the environment. 1. Flying taxis. Flying taxis are no longer just a futuristic concept. They are rapidly becoming a reality. For consumers, this technology will significantly reduce travel time and ease congestion in urban areas. Currently, Joby Aviation and Archer Aviation are leading the charge, with FAA approval for testing. These flying taxis can reach speeds of up to 200 miles per hour, providing an efficient and eco-friendly alternative to traditional ground transportation. For example, Joby Aviation's eVTOL aircraft can travel up to 150 miles on a single charge, with a capacity for 4 passengers. This technology promises to cut urban travel time by up to 80%, transforming the way we move within cities. Aleph Aeronautics has taken it even further by combining the capabilities of cars and airplanes, offering consumers the freedom to drive on the road and take off into the air when needed. Meanwhile, Klein Vision has introduced the world's first officially certified flying car, a 2-seater, marking a significant milestone in the realm of personal transportation. The vehicle comes in 3 different power versions: 280 horsepower, 320 horsepower, and 340 horsepower, equivalent to high-end sports cars or high-performance SUVs. However, the 280 horsepower version is considered the standard production model. Despite being a flying car, the aircar retains the standard pedals and control systems of a regular car. Additionally, a promising contender for the next breakthrough is the Tesla flying car. Elon Musk is planning to produce a fully electric flying car with 2 seats, slated for release in 2027. You might think that a flying car could cost several $100,000 or even $1 million, and we thought the same. However, the price Elon Musk is proposing is a world-challenging figure: $6,789, a beautiful number he believes will leave anyone in awe. Behind this price is a statement to the competition, especially those who copy Tesla's technology. You may steal Tesla's ideas and technology, but to produce at this price, China will need decades of effort. Even more practically, the logistics industry is applying this technology more thoroughly and effectively than ever before. Amazon's Prime Air drones are revolutionizing delivery. These drones can carry packages weighing up to 2.2 kilograms and travel at speeds of 80 kilometers per hour. This means faster delivery times, reduced carbon emissions, and improved convenience for consumers. 2. Autonomous EV technology, Robotaxi. In the U.S., Waymo's self-driving fleet is currently operating in Phoenix, Arizona, offering ride-hailing services to consumers with a safety rate of up to 99.9999%. These vehicles have the potential to significantly reduce accidents caused by human error, which currently accounts for over 90% of road traffic accidents. As of May 2025, Waymo has a fleet of over 1,500 self-driving cars that have completed more than 10 million paid trips, with over 250,000 rides per week in cities like Phoenix, San Francisco, Los Angeles, and Austin. Additionally, Tesla Robotaxi has launched its Robotaxi service in Austin, Texas, starting June 22, 2025, with a fleet of 10 to 20 Tesla Model Y vehicles. The service is currently operating in a geofenced area south of downtown Austin from 6 a.m. to midnight. With Tesla's full self-driving technology, consumers can easily hail a robotaxi via the app without the need for a driver. This system will make transportation more accessible and affordable, especially in cities where car ownership is not necessary. Meanwhile, China's autonomous driving technologies, such as Baidu's Apollo, are also developing rapidly. Baidu's self-driving cars have reached impressive milestones, including test drives on highways, but they still lack the advanced capabilities and widespread real-world deployment seen in Waymo and Tesla's autonomous systems. Tesla's Robotaxi, with its planned fleet and advanced AI capabilities, is expected to become a far more comprehensive and globally scalable solution compared to China's current services. Tesla's development of a fully electric self-driving fleet also positions the company as a leader in green transportation. In China, while electric vehicles are also promising to develop, they are still in the early stages of testing, and safety has yet to fully convince consumers. Tesla's integration of AI into electric cars has set it apart by creating a more advanced connectivity system. 3. Autonomous humanoid robots. Currently, one of the most prominent humanoid robots is Tesla's Optimus Gen 3, developed by Tesla. This robot is designed to perform human-like tasks in industrial and home environments, with the ability to carry heavy loads in a wide range of applications. The Tesla Optimus Gen 3 is equipped with advanced AI, enabling it to carry out tasks such as assembly, cleaning, and assisting the elderly. It is expected that the Optimus Gen 3 will go into mass production by 2026, with a price tag of around $20,000. When talking about the humanoid robot market, we cannot overlook the impressive developments by China's Unitree Robotics. Recently, the company launched its humanoid robot R1, capable of running, performing flips, and executing movements like punching and spinning kicks. The R1 is equipped with multimodal AI, including voice and image recognition, and is priced at approximately $6,000, making it more accessible to consumers. Indeed, the price is quite affordable for the mass market segment, but beyond achieving price competitiveness, the key is scalability and real-world application. As expected, the Optimus robot will be upgraded to Generation 3.5 with many remarkable improvements, with Elon Musk comparing it to a real-life C-3PO from Star Wars. What shocks the entire industry is that Tesla plans to produce this robot for just $10,000, with thousands of Optimus units expected to be operational in factories by 2025. With over 3,000 upgraded tasks, it will evolve into a versatile humanoid robot, capable of being the ultimate homemaker with 22 degrees of freedom in its hands. Meanwhile, Unitree Robotics R1 may have faster running speeds, more agility, and incredible acrobatic abilities, but it is still limited to laboratory settings. On the other hand, the Tesla bot is already working diligently in factories, serving households as the ultimate homemaker, and more importantly, it is directly interacting with customers in restaurants, operating autonomously, and communicating independently. 4. SpaceX Starship and intercontinental speed. SpaceX's Starship has the potential to revolutionize how we travel, not just on Earth but across the entire planet. Starship will make intercontinental travel between cities on different continents a reality, dramatically reducing travel time. For example, a flight from New York to London, which typically takes 7 hours by plane, could be completed in just 30 minutes with Starship, thanks to speeds of up to 27,000 kilometers per hour. Starship is being developed with the goal of providing intercontinental and space tourism services at speeds of 27,000 kilometers per hour, far surpassing current systems. This will significantly reduce travel times between major cities, with a flight from New York to London taking only 30 minutes instead of the 7 hours it currently takes. Starship promises not only to be a vehicle for space professionals, but also a public tourism service, expanding the possibilities of intercontinental travel and space exploration. So, how does it compare to China's Long March? Long March, China's flagship rocket system, has a long and impressive development history. This system has carried out over 200 launches and has played a key role in China's space exploration missions, including lunar flights and Mars exploration missions. The Long March, China's flagship rocket system, currently costs around $50 million per launch. While this is a relatively low price compared to other commercial rocket systems, Long March lacks reusability, meaning that each launch requires the complete manufacturing of new components. In contrast, SpaceX's Starship, with its reusability, has an estimated cost of just $2 million per flight, significantly cheaper than non-reusable launch vehicles. This not only helps Starship save costs, but also increases launch frequency, creating a major difference in the commercial space business model. Furthermore, this system is primarily focused on research and exploration goals, whereas Long March does not aim to serve space tourism or intercontinental transportation like Starship. 5. Developing Hyperloop and high-speed trains. Another groundbreaking and often considered crazy idea by Elon Musk is Hyperloop. Hyperloop is expected to completely revolutionize long-distance travel, reducing travel time from hours to mere minutes. You could easily travel between New York and Washington, D.C. in just 30 minutes instead of the usual 3 to 4 hours by train or car. The Hyperloop system can reach speeds of over 1,125 kilometers per hour, significantly cutting down travel time between major cities. High-speed trains, such as those being developed by Virgin Hyperloop, promise to achieve speeds of 1,125 kilometers per hour, allowing passengers to move between cities in record time. The construction of these systems has already shown impressive results, with Virgin Hyperloop completing a 10.5 kilometers single-track prototype in just 7 months. Similarly, Tesla Hyperloop, Elon Musk's project set to launch in 2026, will feature a completely enclosed capsule, carrying up to 28 passengers, swiftly traveling through low-pressure tubes. The system is designed to depart every 2 minutes or even every 30 seconds during peak hours. And it's not just for people. Plans are underway for larger versions that can carry oversized vehicles. Imagine loading your SUV into a tube and reaching your destination faster than a plane. These capsules will float on air cushions using a technology called air bearings, essentially a flying carpet version of the technology, allowing the capsules to glide with almost no friction. Ticket prices for Hyperloop trips are expected to be as low as $20 to $30, making it a cost-effective alternative for long-distance travel. Compared to high-speed rail, which is much more expensive to build and operate, Hyperloop is expected to save 2 to 3 times the energy and can be built at a fraction of the cost. With an estimated construction cost of around $20 million per mile, Hyperloop is far more affordable than traditional high-speed rail systems, which can cost up to $178 million per mile. The entire Hyperloop system could be built at a total cost of just $6 to $7 billion, lower than some traditional rail systems, and is designed to transport both people and goods at speeds that airplanes and high-speed trains cannot match. Recently, you've probably heard of China's SkyTrain, an exciting new addition to the urban transport system, especially in cities like Chongqing. The SkyTrain operates on a single track, allowing it to travel above ground and providing an interesting solution to urban congestion. However, as we mentioned earlier, it will be highly disruptive for carrying a small number of passengers and is overly dependent on elevated rail infrastructure. It is facing significant challenges in scaling up to mainstream use and is currently being tested in a few high-income cities in China. 6. Smart infrastructure in the United States. Smart infrastructure is revolutionizing U.S. highways, with systems enabling electric vehicles to charge while in motion. Currently, 80% of EV owners charge at home, but public charging infrastructure, especially on long trips, is insufficient. The development of dynamic charging lanes, already in prototype in some cities, will allow EVs to travel longer distances without worrying about charging stops. This system, expected to roll out across major highways by 2030, will cost around $60 billion to implement, but is predicted to save $10 billion annually in reduced charging times and improved transportation efficiency. Autonomous trucks like those from Embark are also proving transformative. These vehicles can reduce delivery times by up to 30%, cutting logistics costs and improving customer satisfaction. The U.S. economy could save over $100 billion annually due to autonomous trucking, including fuel savings and fewer accidents. While China is investing in smart infrastructure, particularly EV charging stations and autonomous vehicle trials, it lags behind the U.S. in integrating wireless charging into road infrastructure. China has yet to implement wireless charging lanes, focusing mainly on static charging stations. In terms of autonomous freight transportation, the U.S. is leading, with over 20,000 autonomous trucks expected on the road by 2025, compared to China's projected 4,000. This difference underscores the technological and infrastructural advances the U.S. has made in creating a more efficient and future-ready transportation system. 7. NASA's Green Aviation Project. NASA's Green Aviation Project represents a bold leap towards sustainable air travel, with the development of emission-free aircraft powered by renewable energy sources like hydroelectric power. By 2035, NASA aims to introduce aircraft that are not only emission-free, but also far more energy efficient than current models. According to NASA, these new aircraft could reduce fuel consumption by up to 30% and cut emissions by more than 70%, offering a greener alternative to conventional air travel. The environmental benefits are not just theoretical. NASA's X-57 Maxwell, an electric aircraft prototype, has already demonstrated a significant reduction in noise and emissions in early tests. The development of hybrid electric engines for commercial aviation is expected to reduce operating costs by 25% compared to traditional jet engines, potentially saving the aviation industry billions of dollars annually. Given the rapid advancements in electric and autonomous vehicle technologies, how should the U.S. balance innovation with infrastructure development to ensure widespread adoption of these technologies? Please share your opinion in the comments section below this video. Thanks for watching our video. Subscribe now so you don't miss the next breaking Tesla update. It's coming in just 2 days. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to turn on notifications so you never miss our latest videos. A completely new era in transportation is beginning, and it's unlike anything humanity has ever seen. A spherical vehicle from Japan is drawing attention not only in the United States, but across the globe. For the first time ever, flying motorcycles and hybrid personal vehicles that can seamlessly switch between the road and the sky have emerged. And what's even more shocking is that these innovations are already undergoing real-world testing in the United States and Japan, with full-scale deployment planned for early next year. The initial rollout is set to launch in 4 major U.S. cities: Los Angeles, Miami, New York, and Chicago, followed by more than 10 major cities across 6 different countries worldwide. Every prototype is ready, and mass production is just around the corner. So what do these groundbreaking machines look like? How do they work? And can they truly become the next mainstream mode of transportation in the near future? Welcome to Tesla Car World. One of the most exciting new ideas in personal flight is the Volonaut Airbike, designed by Polish inventor Tomasz Patan. Patan, who helped launch Jetson, the company behind the Jetson 1 eVTOL, has now revealed a working prototype of this single-seat flying motorcycle. The air bike looks like something pulled right out of a sci-fi blockbuster. Capable of speeds up to 124 miles per hour, it uses a jet propulsion system to lift off and maneuver, allowing for smooth travel through tight spaces where regular vehicles could never go. What makes the design especially appealing is its compact build with no exposed rotors, which adds both safety and efficiency. The rider leans forward in the seat, giving them a full 360-degree view, while an onboard stabilization system keeps the craft hovering steadily and makes handling feel natural. The frame is produced with 3D-printed ultralight carbon fiber, making it about 7 times lighter than a typical motorcycle frame. Although it's only just now being shown to the public, the air bike is already drawing serious interest from tech fans and aviation enthusiasts. There's no official word yet on price or a release date, but engineers are already looking at how it could fit into city transport and even emergency response. With its sleek aerodynamic profile and surprisingly low noise, the air bike is shaping up to be a strong candidate for the future of urban mobility. Over in China, the Moji aircrafting team has been working on a unique flying vehicle, an acranoplan. This vehicle uses the ground effect to skim across water at high speeds, a truly novel concept. Within just 100 days, they constructed a full-scale acranoplan designed to carry a single person. Using lightweight but sturdy materials including reinforced KT panels and aerospace-grade aluminum, the acranoplan is powered by drone-style electric motors and batteries, making it not only powerful, but also eco-friendly. This vehicle is controlled remotely, and during testing it showed impressive stability, speed, and liftoff capability using the air cushion effect. The success of the acranoplan has sparked further interest in adapting it for use in rescue operations, particularly in coastal and lake environments, where its ability to glide just above the water's surface could be a game-changer. As exciting as this is, one must also appreciate the challenge ahead of these pioneers, refining their invention for practical, widespread use in everyday situations. Then there's Toyota's T-Spinner, a spherical vehicle that feels like something straight out of science fiction. This transparent 2-seat vehicle moves and rotates thanks to a mechanism similar to a hamster wheel, controlled by a joystick inside. The T-Spinner's ability to turn in any direction, even in tight urban environments, could revolutionize city mobility. Engineers have worked tirelessly to bring this dream to life, going from a miniature model to a full-scale prototype in just a few months. With plans to add smart glass and heads-up displays for better visibility, this could soon become a part of our urban landscapes, helping solve the long-standing issue of navigating narrow streets. The Artior has also introduced a practical innovation with their Skyrider X1, an aerial scooter that functions both on the ground and in the air. It's an electric scooter that folds into a flying drone, making the transition between road and air seamless. With a flight time of up to 40 minutes and speeds approaching 62.1 miles per hour, it's clear that this is not just a novelty, but a functional step forward in transportation. The X1 is designed with safety in mind, featuring an autopilot system for ease of use. It's exciting to imagine how this vehicle could change the way we navigate crowded cities, but one must remain mindful of the challenges that come with new technology, such as regulatory approval and infrastructure adaptation. Lift Aircraft has also been testing its electric vertical flying vehicle in Japan, marking a significant step in the integration of aerial vehicles into urban transport. Passengers can take a ride without needing a flying license, which could open up air travel to the general public in a way we've never seen before. This vehicle, which uses 8 electric motors powered by lithium batteries, has already drawn positive feedback for its smooth, intuitive operation. The quiet, eco-friendly nature of the aircraft is just another reminder that transportation innovation doesn't have to come at the expense of the environment. In New Zealand, Martin Aircraft Company is working on the Martin Jetpack, a personal vertical takeoff and landing aircraft that has already captured the attention of many. Powered by a V4 gasoline engine, the jetpack can achieve speeds up to 46.0 miles per hour and reach altitudes of 2,500 meters. While it has already proven itself in controlled tests, the company faced financial setbacks a few years ago, which slowed its progress. Nevertheless, work is underway to revive the project, and the potential applications in emergency services and rapid response scenarios could make the jetpack a valuable asset to society. Though the price is steep, ranging from $150,000 to $250,000 depending on configuration, the technology is undeniably fascinating. But like any innovation, there are hurdles to overcome, and it's important to consider both the positives and the challenges as the industry moves forward. Skyrive's SD-05 flying car made its debut at Expo 2025, hovering autonomously for 4 minutes and proving that flying cars might soon become a reality. While Japan is still catching up to China, where EHang has already received approval to operate air taxis, the sky is the limit. These vehicles have the potential to transform urban mobility, but concerns around safety and infrastructure must be addressed before they can become commonplace. The excitement doesn't end there. Jason from the J Laser video channel has revealed his final version of a homemade flying hoverboard, which is inspired by iconic characters like the Green Goblin and Iron Man. This unique project showcases what can happen when passion and engineering collide. It uses 10 electric motors to lift a person into the air, and though it's still a novelty, Jason's future plans include improving its range and altitude. It's a testament to the ingenuity of everyday people pushing the boundaries of what's possible. Moreover, Brazilian engineer Marcelo Labrador's human drone project represents an incredible leap in personal aviation. Built with multiple powerful motors and designed to lift a person into the sky, it's a testament to the do-it-yourself spirit that continues to inspire engineers around the world. This project, while still in its infancy, shows the incredible potential of personal aerial mobility, even when developed on a shoestring budget. These advancements in transportation represent an exciting future, where technology and human ingenuity are coming together to change the way we live. Yet, as we marvel at these breakthroughs, it's important to remember that the road ahead is long, and with innovation comes responsibility. The goal should always be to serve humanity, to make our lives easier, safer, and more connected. The future of transportation is bright, but like all progress, it requires careful consideration and a willingness to learn from the challenges along the way. How can Tesla turn prototypes into mass-market revolutions? While the world is fixated on the surge of electric vehicles and bold visions like flying cars, another revolution is quietly but powerfully unfolding. Tesla and Elon Musk are planning to take that revolution even further. As the global leader in EV sales, the company isn't content with producing familiar sedans and SUVs. Instead, it is pushing boundaries with minibuses, heavy-duty trucks, electric pickups, and even smartphones. These innovations are not only redefining the auto industry, but they also raise a much bigger question. As electric vehicles become more common, more affordable, and smarter than ever before, how will they transform the way we travel, live, and connect with the world around us? Over the past several years, Tesla has continued to cement its leadership in the electric vehicle market. The company now operates a global network of factories and product lines that sustain high-volume production. In the second quarter 2025 alone, Tesla built over 410,000 vehicles and delivered more than 384,000, underscoring its industrial-scale capabilities. From this foundation, Tesla has pushed far beyond its existing lineup, venturing into heavy-duty trucks, pickups, minibus concepts, mass-market hatchbacks, and even futuristic projects like Robotaxis. This multi-pronged strategy shows a company that is unafraid to experiment broadly, driving rapid innovation, but also facing operational hurdles. One notable concept is the Tesla minibus, inspired by the classic microbus but built on a modern EV platform. With floor-mounted batteries, compact motors, and autonomous or semi-autonomous driving potential, the minibus is envisioned as a flexible, congestion-reducing alternative to traditional buses. Still, large-scale production remains tied to safety trials and regulatory approvals. In the mass-market segment, Tesla has long been rumored to be working on a low-cost hatchback referred to as Model 2 or Model Q, originally pitched as a $25,000 EV. While highly anticipated, this program has gone through significant shifts. At times, Tesla reportedly deprioritized the affordable car in favor of robotaxi development, only for leadership to later suggest both tracks remain possibilities. The bottom line is that Tesla still recognizes the importance of an entry-level EV, but the timeline and exact form remain uncertain as profitability and autonomy increasingly shape strategy. In commercial transport, the Tesla Semi illustrates both ambition and execution challenges. The first trucks were delivered to PepsiCo in December 2022, Yet broader rollouts have been slow, with only partial fulfillment of PepsiCo's order so far due to production and battery constraints. More recently, Tesla has been expanding hiring for the Semi program with the goal of ramping up output in coming years. The Semi highlights the technical promise of zero-emission trucking, but also the steep climb from prototype to scaled manufacturing. The Cybertruck remains Tesla's most daring step in automotive design, and while its early path was rocky, signs of real momentum are now visible. After multiple postponements, low-volume production started at Giga Texas in mid-2023, with the first customer handovers happening by November that year. Tesla initially envisioned up to 250,000 units annually, but reality proved tougher. In its first full year, deliveries reached roughly 41,000 units. Tesla has not shied away from addressing these challenges. To counter slower-than-expected sales, the company rolled out discounts of as much as $10,000 and rebalanced labor toward higher-volume vehicles such as the Model Y, easing inventory pressure. Even so, the Cybertruck program delivered about 5,000 vehicles in the second quarter of 2025, a figure that highlights steady output and supply chains that are holding firm. Production capacity is also being reinforced. Updates to the assembly lines at Giga Texas are underway, with a stated target of 2,500 trucks per week by the end of 2025. This ambition dovetails with Elon Musk's broader pledge to double production volumes across Tesla's U.S. operations in the coming years. Beyond North America, Tesla is positioning the Cybertruck for international reach. Deliveries to Saudi Arabia, the UAE, and Qatar are expected to begin before the close of 2025, marking the model's first expansion into overseas markets. Challenges, however, remain part of the story. A recall issued in early 2025, covering more than 46,000 vehicles built through February, was linked to adhesive problems affecting body panels. Yet despite such setbacks, the Cybertruck closed out 2024 as the top-selling electric pickup in the United States, with cumulative sales approaching 39,000 units. On the battery front, Tesla's strategy has been a hybrid of internal breakthroughs and external partnerships. The much-publicized 4680 cells have seen early production hurdles, while LFP batteries sourced from Chinese suppliers like CATL and BYD are increasingly deployed in standard-range vehicles, thanks to their lower cost and strong safety profile. The company's battery roadmap remains central to its ability to lower costs per kilowatt-hour and expand vehicle affordability. Tesla has also begun shifting toward mobility services with its Robotaxi Cybercab project. At the 2024 We Robot event, Tesla revealed a Cybercab prototype and announced a goal of scaling production around 2026. In 2025, Tesla launched pilot programs in Austin under supervised trials, aiming to lay the groundwork for autonomous ride-hailing. If successful, this pivot could reshape Tesla's revenue model, but the venture faces significant regulatory, legal, and technical obstacles. Outside of vehicles, speculation about a Tesla Pi phone remains widespread online. To date, however, Tesla has made no official confirmation, and Elon Musk has repeatedly downplayed or dismissed the idea. Until further notice, the Tesla phone remains an unverified rumor rather than an actual product roadmap. Broadly speaking, Tesla is pursuing a dual strategy. On one hand, the company is focused on optimizing mass production of its established products such as the Model 3 and Model Y, along with energy solutions like the Megapack, which provide a stable foundation for revenue and market presence. On the other hand, Tesla is channeling significant resources into forward-looking projects, including Robotaxi, the Cybertruck, the Semi, and next-generation battery technologies, to secure its leadership in the future of mobility and energy. Together, these two priorities illustrate how Tesla is working to balance short-term operational strength with long-term innovation, ensuring both current stability and future growth. This dual strategy has yielded impressive milestones but also recurring headwinds, from production delays and supply chain bottlenecks to safety recalls and the uncertain path to full autonomy. Looking ahead, Tesla leadership has set bold production and cost reduction targets, including slashing cost per kilowatt-hour and scaling Robotaxi to millions of units. Yet, as investors and consumers have learned, such ambitious claims must be weighed against real-world execution challenges. Tesla's trajectory over the past decade represents one of the most remarkable leaps in the global auto industry. The company has not only accelerated EV adoption, but also pushed battery, software, and mobility concepts into mainstream debate. At the same time, scaling innovation into reliable, profitable, and regulated products is proving to be a marathon. Tesla's disruptive force is undeniable, but the next phase of growth will demand equal parts ambition and operational discipline. Why is Tesla expanding beyond cars into ecosystems? Tesla has long transcended its identity as an electric vehicle maker. Today, it is constructing a complete ecosystem that spans energy, intelligence, and even consumer electronics. This transformation is most visible in the company's energy division, which has grown into a breakout star rather than a side project. In 2024, Tesla deployed 31.4 gigawatt-hours of battery storage through its Powerwall and Megapack systems, more than double the 14.7 gigawatt-hour deployed in 2023, representing over 3,000% growth since 2018. To put this in perspective, Tesla's deployments alone nearly match the entire U.S. energy storage sector's total of 34.4 gigawatt-hours in 2024. Revenue reflects this surge, with Tesla's energy storage business generating $2.4 billion in Q3 2024, a 52% year-over-year increase, now accounting for nearly 10% of Tesla's total revenue. Supporting this growth, a new Megapack factory near Houston is expected to add 1,500 jobs, and alongside existing sites in California and Shanghai, push combined annual capacity to 40 gigawatt-hours. Beyond large-scale batteries, Tesla is turning homes into grid assets with over 750,000 Powerwall units installed globally and nearly 100,000 participating in virtual power plant programs. How can flying motorcycles and spherical cars be the future if basic EVs still face delays? Please share your opinion in the comments section below this video. Thanks for watching our video. Subscribe now so you don't miss the next breaking Tesla update. It's coming in just 2 days. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to turn on notifications so you never miss our latest videos. Just about 10 years ago, we knew China primarily for its ability to produce cheap goods, while its cars and high-tech innovations were nowhere near a match for the United States. But today, we witness China producing millions of electric vehicles, with their own proprietary batteries and even cars that can swim. We must admit, they have far surpassed the world's imagination. Humanoid robots, surgical robots, and the high-speed trains in Shanghai remind us of the feeling we had when watching the Jetsons, the animated show we grew up with. The difference now is it's no longer a fantasy, it's a reality. But to be honest, right now, we feel both excited and anxious. Excited because future generations will be able to travel faster, live more modern lives, and experience a world that mirrors the sci-fi movies we watched when we were younger. Yet, we can't help but feel a sense of unease. Will these vehicles truly be safe? Will our cities have the infrastructure to handle fleets of flying cars, spherical vehicles, or passenger-carrying drones? Welcome to Tesla Car World. There's no denying that Chinese engineers are truly exceptional in the field of technology. Looking at the current pace of economic development in this country, experts all agree that the race for the future is shifting in China's favor. For decades, we in the United States grew up in a world where America was the undisputed leader. From the Cold War to the dawn of the Internet era, we were always confident that American technology would lead the charge. Yet, as we approach 2025, it's hard not to feel a sense of unease. As we've just crossed into the second quarter of 2025, the unthinkable has happened. China has overtaken Tesla in terms of revenue. This isn't just a minor shift in the global market. It's a fundamental change in the landscape of innovation and leadership. We can't help but ask ourselves, will our children still grow up in a world where the United States leads the charge in global advancement? Of course, a part of us, the part that understands the benefits of healthy competition, sees this shift in a positive light. We know that competition drives better products, lower prices, and improved technologies. This can only be good for consumers around the world. But there's another part of us, the part that has always revered the Made in the USA label, that feels a sense of loss. So, how are humanoid robots impacting human interaction? It's clear that humanoid robots have become a major focus for manufacturers. New developments are announced regularly, with updates arriving almost every day about the latest humanoid robots from emerging robotics companies. Just 2 years ago, the only players in the game were Boston Dynamics and Tesla. Now, China is pouring significant resources into humanoid robots, and it feels like nearly every company is joining in. This shift is certainly exciting, and we're enthusiastic about seeing how it evolves. Right now, the Optimus and Unitree G1 robots are getting a lot of attention. Now the G1, a modern humanoid robot recently introduced by scientists. It boasts incredible flexibility, placing it among the most advanced humanoid robots currently available. Discussing the appearance and design. Much like Optimus, Tesla has upgraded from Gen 1, launched in March 2023, to a more refined version, Gen 2, released at the end of last year. This update has significantly improved the Tesla bot's look, making it far more polished and visually appealing. In comparison, Unitree has progressed from the H1 to the current G1. Fairly speaking, the design of the Unitree humanoid robot has undergone a complete transformation, making it far less intimidating than before. The H1 model had a full black body that could easily frighten children if brought home. Even dressed in a branded shirt, the design didn't leave much of an impression. However, when the Unitree G1 came out, it struck a balance of freshness and familiarity, almost reminding us of something Boston Dynamics unveiled earlier this year in April. We hate to say it, but the Unitree G1 is about 70% similar to the Atlas Gen 2 robot. Even the promotional video could confuse anyone into thinking the two robots were one and the same. In contrast, Tesla's Optimus Gen 2 introduction was straightforward, but memorable, largely due to the details presented. Whether or not Unitree drew inspiration from Boston Dynamics is up for debate, but what's clear is that the G1 is much smaller and more compact than its predecessor, the Unitree H1. The H1 stood at a height of 5 feet 11 inches, which is closer in size to Optimus Gen 2. However, the G1 is about the size of an average 8-year-old child, with a height of 4 feet 2 inches. When it comes to size, Optimus aligns more with the ideal proportions for a humanoid robot, as most other humanoid robots tend to be around 5 feet 8 inches or taller. Of course, this doesn't mean Optimus will necessarily outperform the Unitree G1, as each size has its own advantages. For example, Optimus would be better suited for industrial environments or spaces requiring a higher reach, where objects are positioned beyond the reach of children or the elderly. On the other hand, the Unitree G1 might excel in tight spaces or tasks demanding greater flexibility. Tesla's Optimus is constructed primarily from lightweight metals like aluminum, plastic, and carbon fiber, with a mix of 40% metal and 60% impact and scratch-resistant casing. As a result, Optimus has a well-balanced design and has earned the reputation of being the best-designed humanoid robot so far. The reported weight of the Tesla humanoid robot is 138 pounds, a noticeable reduction from the original 160 pounds. On the other hand, the Unitree G1 is surprisingly light, weighing just 77 pounds. It's composed of about 90% metal, mostly aluminum, with plastic used for the head and feet. Typically, a robot with a stable weight like Optimus would have an edge when it comes to balance, despite potentially sacrificing speed. However, the Unitree G1 demonstrates exceptional balance. In its promotional video, it remains upright even when pushed, which is something Tesla has yet to test with their humanoid robot. So yes, it's undeniable that the Unitree G1 is quite impressive. Tesla employs neural network-based sensors in its full self-driving FSD software, paired with multiple 2D cameras for wide-angle environmental monitoring. In contrast, the Unitree G1 robot is equipped with 3D LiDAR and Intel RealSense D435 depth cameras. These advanced sensors provide a strong hardware foundation, enhancing the G1's ability to perceive and understand its surroundings with greater accuracy and sensitivity. Moreover, Elon Musk has mentioned several times that the future versions of Optimus, possibly Gen 3 or Gen 4, will feature 22 degrees of freedom. Degrees of freedom refer to the number of independent movements a robot's joints and body parts can make. In humanoid robots, the more degrees of freedom, the more flexibility the robot's movements have. Eventually, with 27 degrees of freedom, like a human hand, a robot's actions would be virtually indistinguishable from human capabilities. In contrast, Unitree offers the G1 humanoid robot with an optional 3-fingered dexterous hand that can be equipped with haptic feedback. Through a hybrid force position control system, the G1 can simulate the precise operations of a human hand, performing tasks with exceptional accuracy and stability. Whether it's cracking walnuts, carrying heavy loads, or handling fragile objects like eggs, the G1 shows remarkable precision. Additionally, it can handle delicate tasks like opening soda bottles and even welding. While the exact number of degrees of freedom in the G1's hand is not specified, it's clear that its capabilities are just as impressive as Optimus's. Expanding beyond the hands, the Unitree G1 offers a significant range of joint movements, with 23 to 43 joints and a maximum joint torque of 120 Newton-meters. On the other hand, Tesla's Optimus features 28 joints with 14 rotary actuators and 14 linear actuators. Tesla has demonstrated Optimus performing tasks like jumping, yoga, and highly flexible squats to showcase its agility. Similarly, Unitree has proudly displayed the G1's ability to perform high-load dynamic movements, such as standing up, folding chairs, and swinging sticks. When comparing the operations and versatility of both humanoid robots, it's tough to pick a clear winner as they cater to different approaches. It's like comparing two movie genres, a romance and an action film. Optimus focuses on precise, gentle movements with an emphasis on dexterity, while the Unitree G1 is more decisive and brute force, displaying raw power. Ultimately, both robots shine in their own right. However, as of now, the G1 still requires remote control to operate. Currently, it is only available for purchase by tech companies and universities, and there is no version designed for practical real-life applications such as cooking, housekeeping, or assisting with tasks in factories like the Tesla bot Optimus. Priced at $16,000, it remains a luxury item, with even celebrities buying it just to make unboxing videos. While users can imagine that, in the future, it might assist with tasks like brewing coffee or helping around the house. Its battery life is quite limited, lasting only about 2 hours due to its small battery capacity. To be honest, the humanoid robot market in China is rapidly growing, and it is outpacing many long-established brands in the industry today. Take a look at a visit to a humanoid robot manufacturing facility in Shandong Province, where these robots are being built. Here, EX Robot, a company specializing in humanoid robots, showcases their most advanced creations. This company is not only designing robots that can mimic human movements, but is also researching the development of robots with the ability to communicate and possess a level of self-awareness almost identical to humans. There are certainly many fascinating aspects to explore when comparing these two robots. If you'd like us to dive deeper into their differences, strengths, and potential, don't hesitate to leave a 1 in the comments below this video. We'll see you soon in the next Tesla Car World video. Thanks. What are smart cities in China? Now, China is redefining the very fabric of technological and industrial development with its bustling cities, revolutionary factories, and innovative labs, uncovering the truth about the race to the future. But the ultimate question remains: can China surpass America in the technological arms race? For example, Shenzhen, a city that just a few decades ago was a small fishing village. Now it stands as the epitome of futuristic ambition. Here, the landscape is dominated by towering skyscrapers and an ever-evolving tech ecosystem that rivals Silicon Valley in the West. Shenzhen is where dreams are turned into reality, where the ideas that define tomorrow are being born today. This city is home to BYD, the world's largest electric car maker. Last year, it surpassed Tesla in revenue. Its Blade battery, a revolutionary lithium iron phosphate battery, is a key part of this success. With the ability to charge up to 248 miles in just 5 minutes, BYD is setting the pace in the electric car industry. And for the first time in history, we witnessed a car that can literally swim, built for the challenges of flooding and extreme weather. Smart cities in China represent the fusion of cutting-edge technology and urban planning to create more efficient, convenient, and responsive living environments. At their core lies the city brain, a centralized system that harnesses real-time data from sensors, cameras, and connected devices to optimize everything from traffic flow to public services. In Hangzhou, residents notice fewer red light stops and shorter commutes thanks to the Urban Brain Project, which analyzes live traffic data and dynamically adjusts signal timings. During peak hours, commute times have decreased by more than 15%, transforming daily drives from a source of frustration into a smooth journey. In Xiong'an area, 95 miles of digital roads equipped with smart lampposts automatically optimize traffic flow, reducing congestion and unpredictable delays. Smart cities simplify bureaucratic processes through integrated digital platforms. In Xiong'an, the cloud-based Cloud Window allows residents and businesses to apply for permits and complete government transactions entirely online, eliminating the need for in-person visits and slashing waiting times. Hangzhou's goal of only once service visits has already achieved a 97% success rate, with citizens completing most public tasks in a single trip. The next target is not even once, where smartphone apps handle everything remotely. Consumers benefit from proactive city maintenance and public safety systems. In Xiong'an's Rongdong district, over 1,000 AI-equipped cameras detect 19 types of municipal issues, such as overflowing trash bins or illegal parking, and alert community workers instantly, ensuring faster resolution and a cleaner neighborhood. This level of responsiveness reduces health hazards and contributes to a more pleasant urban environment. Smart cities integrate IoT sensors and green technology to monitor air quality, water usage, and energy consumption. Through edge computing and AI, building ventilation and street lighting adjust automatically based on real-time weather and occupancy data, which helps lower utility bills for families and decreases carbon footprints without sacrificing comfort. In Hangzhou, big data platforms track energy usage across public facilities, enabling targeted conservation measures that deliver both cost savings for residents and environmental benefits. By connecting hospitals, ambulances, and traffic systems, China's smart cities improve emergency response times. Hangzhou's traffic management algorithms prioritize green signals for ambulances, ensuring they reach hospitals faster, a critical advantage for patient outcomes. In addition, integrated health apps allow consumers to schedule medical appointments, renew prescriptions, and receive telemedicine consultations directly from their smartphones, saving time and reducing crowding in clinics. How truly superior are Chinese supercars? The Tesla Roadster, which boasts a mind-blowing 1,100 horsepower, accelerates from 0 to miles per hour in under 1.9 seconds, setting a precedent in electric hypercars, challenging the likes of Rimac Nevra and showcasing Tesla's innovation. However, the NIO EP9 pushes the envelope further with 1,341 horsepower and a 0 to 62 miles per hour time of 2.7 seconds, managing to break records at the Nürburgring. Although Tesla has long dominated electric performance with its autopilot features and rapid acceleration, the NIO EP9 offers more outright raw power, setting new benchmarks for Chinese engineering that directly challenge European titans. The EP9's sub-7-minute Nürburgring lap is a statement not only of speed, but also of China's growing capability in both manufacturing and racing technology. In contrast, while Tesla's Roadster offers remarkable acceleration and insane performance metrics, NIO's EP9 delivers track-ready performance with a finesse few American-made cars can match at this price range. NIO has managed to keep the car's production figures low, preserving its exclusivity, a feature Tesla has historically struggled with, focusing more on scalability. While Chinese supercars like the NIO EP9 and Xiaomi SU7 Ultra deliver impressive performance numbers, when compared to the Tesla Roadster, the value it offers is truly remarkable. With 1,100 horsepower and the ability to accelerate from 0 to 60 miles per hour in under 1.9 seconds, the Tesla Roadster is not only one of the fastest electric vehicles, but also provides exceptional performance at a starting price of $200,000, which is significantly more affordable than its Chinese counterparts. The NIO EP9 comes with a price tag of $1.48 million, while the Xiaomi SU7 Ultra is priced around $700,000. Even though both of these cars boast impressive power and performance, you can own a Tesla Roadster for a much lower price, while still enjoying the cutting-edge technology, fast charging capabilities, and access to Tesla's global supercharger network. This makes the Roadster not only a high-performance machine, but also a more affordable, long-term ownership option. Additionally, the Tesla Roadster shines not just in performance, but also with its AI technology and autopilot system, allowing owners to experience an advanced and convenient driving experience. This makes the Tesla Roadster a better value compared to Chinese supercars, offering exceptional features without compromising on performance or technology. With its affordable price and top-tier performance, the Tesla Roadster is truly the optimal choice for those wanting to own a modern electric supercar without paying the steep prices typically associated with Chinese models. Ford's GT, renowned for its motorsport roots, offers a thrilling 660 horsepower V6 engine and unparalleled craftsmanship, a true piece of American automotive pride. So, which technology do you think has the edge? We'd love to hear your thoughts, so drop a comment below. We hope this video gave you some interesting insights into the ongoing technological battle. If you enjoyed it, please hit the like button and subscribe to Tesla Car World for more great content. Don't forget to ring the bell to stay updated with all our latest videos. Your feedback means the world to us. Thank you for watching, and we'll see you in the next one.